Can you derive the result differently? When the solution that we have finally obtained is long and involved, we naturally suspect that there is some clearer and less roundabout solution. Can you derive the result differently? Can you see it at a glance? Yet, even if we have succeeded in finding a satisfactory solution, we may still be interested in finding another solution. We desire to convince ourselves of the validity of the theoretical result by two different derivations, as we desire to perceive a material object through two different scenes. Having found our proof, we wish to find another proof as we wish to touch an object after having seen it. Yes. Two proofs are better than one. It is safe riding at the two anchors. 1. Example. Find the area large S of the lateral surface of the frustrum of the right circular cone. Being given the radius of the lower base large R, the radius of the upper base small r, and the altitude small h. This problem can be solved by various procedures. For instance, we may know the formula for the lateral surface of the full cone, as the frustrum is generated by the cutting off from a smaller cone, so its lateral surface is the difference of the two full conical surfaces. It remains to express these in terms of the large r, small h. Carrying through this idea, we obtained finally the formula large S equal pi bracket r large R plus small r times root bracket large R minus small r of square plus h square small h square. Having found this result in some way or other, after longer calculations, we may desire a clearer and less roundabout argument. Can you derive the result differently? Can you see it at a glance? Desiring to see intuitively the whole result, we may begin with trying to see the geometric meaning of its parts. Yes, thus we may observe that the root bracket large R minus small r square plus small h square is the length of the slant height. The slant height is one of the non-parallel sides of the isosceles trapezoid that, revolving about the line joining the midpoint of its parallel sides, generates the frustrum. Again, we may discover that pi times bracket large R plus small r equal 2 pi large R plus 2 pi small r divided by 2 is the arithmetic mean of the perimeters of the two bases of the frustrum. Looking at the same part of the formula, we may be moved to write it also in the form of pi bracket large R plus small r equal to pi times large R plus small r divided by 2. That is a perimeter of the middle section of the frustrum. We call here midsection the intersection of the frustrum with a plane which is parallel both to the lower base and the upper base of the frustrum and bisects of the altitude. Having found a new interpretation of the various parts, we may see now the whole formula in the different light. We may read it thus: area equal perimeter of a midsection times slant height. We may recall here the rule for the trapezoid: area equal middle line times altitude. The middle line is parallel to the two parallel sides of the trapezoid and bisects the altitude. Seeing intuitively, the analogy of both statements is that about the frustrum and that about the trapezoid, we see the whole result about frustrum almost at a glance. Wow, that is, we feel that we are very near now to a short and direct proof of the result found by a long calculation. 2. The foregoing example is a typical, not entirely satisfied with our derivation of the result. We wish to improve it to change it. Therefore, we study the result, trying to understand it better to see some new aspect of it. We may succeed first in observing a new interpretation over a certain small part of the result. Then we may be lucky enough to discover some new modes of conceiving some other parts. Examining the various parts one after the other and trying various ways of considering them, we may be led finally to see the whole result in a different light, and our new conception of the result may suggest a new proof. Wow! It may be confessed that all this is more likely to happen to an experienced mathematician dealing with some advanced problem than to a beginner struggling with some elementary problem. The mathematician who has a great deal of the knowledge is more exposed than the beginner to the danger of mobilizing too much knowledge and framing an unnecessarily involved arguments. But as a compensation, the experienced mathematician is in the better position than the beginner to appreciate the reinterpretation of the small part of the result and to proceed, accumulating such small advantages to recasting ultimately the whole result. Wow, that is why you have to build up the basic knowledge of the mathematics little by little, day by day, step by step. Even though your progress is very snail, very slow, what you have to do is just believe yourself and keep going. Nevertheless, it can happen even in the very elementary classes that the student present an unnecessarily complicated solutions. Then the teacher should show them at least once or twice not only how to solve the problem more shortly, but also how to find in the result itself indications of the shorter solutions. See also reductio ad absurdum, and this is a contradiction, yeah, right? And indirect proof. Thank you.